Okay, let's consider this example. It's very similar to the example that we worked before, except that here the rod cannot be ignored. It has a mass of 5 kilograms. Now again, this distance here is 1 meter. Each of the masses is 2 kilograms. So this distance is also 1 meter, but the mass of the rod is 5 kilograms. Now, the moment of inertia of the overall system is I1 for mass 1 plus I2 for mass 2 plus I3 for the rod. Now, I1 is going to be M1 R1 squared, which is 2 kilograms times 1 meter squared, which is in this case 2 kilogram meter squared. I2 is M2 R2 squared, and in this case M2 is again 2 kilograms, and the distance from the axis is again 1 meter, so it's the same value, 2 kilogram meter squared. Now for I3, that's the moment of inertia of a stick that's rotating about its center. If we go look back at our table, that's what we have. The table tells us it is 1/12 of ml squared, where L is the overall length of the stick. It's 1/12 of ml squared. So in this case, L is 2 meters. That's the overall length. So L is 2 meters. And my equation is 1/12 of ml squared. So in this case, that's going to be 1/12 of 5 kilograms times 2 meter, that's the overall length of the stick, squared. Now 2 meters squared is 4 over 12, that gives us 1/3, so it's 5/3 of kilogram meter squared. 5/3, I think that's 1.67. 1.7 kilogram meter squared. So the overall moment of inertia is going to be the sum of all these three. So I'm going to write it on top here. So that's going to give us, the overall I is going to give us 2 kilogram meter squared plus 2 kilogram meter squared plus 1.7 kilogram meter squared. So this is going to be 2 plus 2, 4 plus 1.7, that's 5.7 kilogram meter squared. Okay. Let's work another example. Now here we have a hoop of mass 5 kilograms and a diameter, that's from here to here, 1 meter, and we are told that these two rods or spokes, their masses is 0.5 kilograms, and we are asked to find the rotational inertia of the system. Like we did in the previous case, the rotational inertia is going to be I1, that's for the hoop, plus I2 for rod 1, plus I3 for rod 3. Now, when we consider the hoop, we look at our equations. A hoop or cylindrical shell, it's mr squared. All the mass is the same distance away from the axis of rotation. So in that case, it's going to be the mass of the hoop times the radius of the hoop squared. Now in this case, we are given the mass of the hoop, that's 5 kilograms. The radius is not given, but we are given the diameter. The diameter is 1 meter, so it's 0.5 meters squared. That's my I1. Okay, so we have to calculate that. So 0.5 squared, that should give us 0.25 times 5, that should give us 1.25 kilogram meter squared. Now for I2, it's just a rod that's been spun about the middle. And I3 is the same thing. So I2 is equal to I3. And remember, the equation was 112 ml squared. So in this case, it's going to be 112 m, which is 0.5 kilograms, and L is 1 meter squared. So in this case, that's going to be 0.5 over 12, 0.04 kilogram meter squared. So my overall moment of inertia, the largest component is due to the hoop. So that's 1.25 kilogram meter squared, plus I2 plus I3, which is twice that much, which is plus 0.08 kilogram meter squared. So that gives us 1.33 kilogram meter squared.